All right, it looks like we are live. Welcome to the first Wednesday of the month. This is the Penwell Fire Engineering ISFSI Focus on Training Humpday Hangout. We got a very interesting topic today and some great expertise on our relatively small panel today, but we got some heavy hitters today, so it should be a good time. We're going to talk about the partnership that ISFSI did with UL to develop the Understanding and Fighting Basement Fires program. So it should be some good discussion today. My name's Brad French. I'm a lieutenant at the Dayton, Ohio Fire Department and also a board member for ISFSI. We have Aaron Heller with us, who we'll introduce in a second, as well as Dan Madrzykowski from UL. We may have a few other panel members jump on as we go here, but we're running with a little bit of a skeleton crew today, so we'll make it happen as we go. But welcome, everybody. As we go throughout the next hour, if you have questions that you want to toss out to myself or Dan or Aaron or anything about this basement fires topic, use hashtag FETalk on social media, and I'll kind of try to glance at my phone every once in a while, or Sarah behind the scenes can keep an eye on that as well, and we'll see if we can pick up your questions as we go. Normally, I would kick it over at this point to our kind of elder statesman, our senior man, if you will, Bobby Halton, editor-in-chief of Fire Engineering. I don't believe he's going to join us today. He might pop in here at some point. But if he were on here today, my guess is that what he would say would be to remind everybody that the call for presentations for FDIC International 2019 is open and on the website. So we're all just kind of coming down off of that FDIC week. We were joking earlier before we went live on air, the fact that there's a little bit of a recovery period after you come back from such an intense week of training, and your spirits are lifted, and you're really high on the profession and your interaction that you had with everybody over there, and all the great classes that you took, and all the lessons that you want to bring back and incorporate in your organization. And so we're all kind of trying to get back into the normal groove after that awesome week over there. But for anybody out there listening that's interested, please go to the FDIC website and look at the 2019 call for proposals. I have no doubt that everybody here on the panel will be putting in for stuff next year as well, and always looking forward to it. FDIC is a tremendous thing, and I don't have the number of days off the top of my head, 300 and something already counting down for FDIC 2019, so it should be great. So what I'll do first is kick it over to my co-host, Aaron Heller, let him do an introduction and kind of give us his thoughts on his own experiences with basement fires and whatever else he'd like to chime in on. Aaron, it's all yours.
All right, thanks, Brad. For those who don't know me, my name's Aaron Heller, and I'm a captain in Hamilton, New Jersey, a former volunteer chief in a little town called New Egypt, New Jersey, and I've had the privilege to run a training company for several years. So unfortunately, about halfway through the show today, I've got to jump off and get on the highway to somewhere out in western Pennsylvania, Marion Center, Pennsylvania, where I'm presenting a survival class tonight. But I'm happy to be here for the first half of the show for sure. Before I get started, since we're just coming back from FDIC, and it really was another great week, I wanted to throw a shout out to the fellow who was my site supervisor for the Commercial Fireground Operations Hot class. His name is Paul Martin. He's retired Deputy District Chief from Chicago Fire Department, and Paul's going to be going and having some procedures done here in the next week or two. And I just want to say that, you know, our prayers are with him, because he is by far one of the nicest gentlemen and biggest helps at FDIC I could ever have. I got lucky that I got paired up with Paul. So praying for his health and everything goes well. So that's that for that part. As far as Indy goes, I just want to, I know Bobby would be saying it, but we want to thank everybody for all the participation. Again, record-setting numbers. The classes were full. People were really focused. All the students that we saw were just home runs. Everybody was into the job and really, really enjoying what they were doing. Great questions, great interaction, and it was cool. It was really cool, like always, but it just seems to get better and better. And I think some topics were talked about this year that, you know, our pendulum swings back and forth every year. And I think the pendulum swung a little bit again this year, and there were some great conversations between some like-minded and unlike-minded individuals. So I really enjoyed seeing some of that and listening to some of that. So It's only about 50 weeks away, so get those proposals in, and we're going early next year in 2019. So that being said, talking about basement fires. Basement fires here in my part of New Jersey are very common. I've been to a lot of basement fires throughout my career in both the volunteer and career side of the departments. And, you know, we didn't always have great understanding of them. We didn't always have great understanding of exactly what was going to happen based on our actions or based on our inactions. So having a study and having IFSI and UL pair up with this and really deliver us true scientific data to go along with the field experience that a lot of us have is going to be very, very helpful for those of us doing it right now and those of us who are going to be doing it long into the future. So, you know, for those of us who've been in basement fires, whatever you want to call it, cellar fires, walkout fires, it's not the same game as the bedroom fire on the second floor. It's not the same game as the kitchen fire. It takes a little more oomph to get that line down those set of stairs and face what you're about to face. So you know, the old days, they would say this separates the men from the boys. I would say this separates the firefighters from the t-shirt wearers sometimes. So I'm looking forward to today's conversations on it, and I know that Dan's research and UL's research is right on the money, and this is what we need. So I would suggest we take it, we apply it as best we can for our departments, our situations, the type of construction we go to, and let it help us. So I'm looking really forward to it. So thank you.
Yeah, absolutely. Excellent. Thank you, Aaron. So what I'd like to do, Dan, I want to just a quick intro. You're one of the few in the industry that probably needs no introduction at this point, but just a quick introduction about yourself and your role at UL, and then we'll kind of roll into the project.
So I'm one of the research engineers at UL, and very fortunate. I spent 32 years at NIST leading the firefighting technology group there, and NIST kind of is interested in some other things. Wildland urban interface and structural collapse are their current big thrust areas, and had an opportunity 2.5 years ago to come to UL and basically continue the mission that we started 15-20 years ago to help the fire service get a better understanding of fire dynamics, fire behavior, and how that can help you with your actual firefighting on the fire ground and make you more effective. So that's been a push. And so we've continued on with that. Really enjoyed leading the project for ISFSI in terms of the UL side on the research. We built a structure last summer, and we kept running fire experiments in that structure, re-instrumenting it each time, putting in new fuel loads each time, replacing interior finish, whatever we needed to fix to get it back to as close to new as we could. And then running the next experiment to look at the different impacts of either nozzles or attack strategy, or just what impact different ventilation had on the structure. And so we learned a little bit about some fire dynamics in below grade fires, as well as learned quite a bit about tactics for below grade fires. So that's a continuum of various things we work on. We do a lot of reviews for NIOSH. So we're still pretty involved with the line of duty deaths, and understanding the line of duty deaths in many cases led us to some of the research questions that the technical panel had. And you might want to say something about that, but I just thought that the ISFSI put together a wonderful tech panel for the Basement Fires Project, because it included fire chiefs that have experienced line of duty deaths, or fire officers that were in the department that experienced a line of duty death due to a basement fire. And so they brought that experience to the tech panel, and other folks such as with the IFC, Chief Morris, that had also conducted an independent study of line of duty deaths on basement fires. So again, between knowing where the literature took us from research and where the research gaps were, and then also what we needed to know based on field experience, bringing those two things together was sort of the perfect blend of information to design this project.
Yeah, absolutely. And without any further ado, I definitely want to dive right into the nuts and bolts of that project as far as how that went. Just as Dan said, this was something that was a partnership between the ISFSI, the International Society of Fire Service Instructors, and UL, funded through an Assistance to Firefighters grant project. And so there was the research burns that happened over at the Delaware County Emergency Services Training Center over outside of Philadelphia. We'll put up a picture here in just a second so you can see that building, and we'll let Dan speak to it a little bit more. But it was a great partnership between ISFSI and UL. And Dan, publicly, I can't possibly thank you personally enough for all of the work hours that you had into this project, as well as your entire team at UL. I hope that you're proud of the product. I have the great privilege of being one of the instructor cadre for the program, along with a lot of other great guys. Another gentleman that's on our typical panel here for our Humpday Hangouts, Tony Carroll, a battalion chief in Washington, D.C. Fire. And obviously one of the case studies that's highlighted in that program is the Cherry Road fire that NIST did an extensive fire modeling on, many years ago. I believe 1999 was the Cherry Road fire, one of the early FDS models, I believe. You can certainly speak to that on a much more technical level than I can. But anyway, it's a great program, and it was a great partnership. So Sarah, if you want to flash up that cover picture, if you will, of the structure, we'll let Dan speak a little bit to the layout and the instrumentation and some of the nuts and bolts behind the scenes with the actual structure itself.
So Sarah, it's still small.
Yeah, we'll see if we can get it to go full screen here. Stand by. While she's working on that, Dan.
There we go.
Okay, there we go. Now we're in business.
So Understanding and Fighting Basement Fires was the title of the project, and it's the title of the UL report, and also the title of the course, 8-hour course that was developed that ISFSI is currently delivering around the country. So what you're looking at in that photograph is the version of the house where it's vented as a walkout basement. So you see flames coming from the area where we had a glass sliding door, 6 feet wide, 80 inches tall. You also see flames above the deck where a kitchen window failed, which is close to the top of the stairs. And you see heavy smoke pouring out the sliding glass doors that lead onto the deck upstairs that are on verge of failure as well. So the deck was laid out in a way that if we wanted to assume and blocked up all the openings to the basement itself and assume the basement was basically 100% underground and below grade, and the only way that you could approach the fire would be from ground level in the rear or in the front, and then going interior and going down the stairs. That was sort of one scenario. Then we had a second scenario, and you can sort of see the deck on the side to the right of the picture. And that deck was just below small side windows that led into the basement. And in that case, we had limited access. And that meant that you could stick a line in the window, but you couldn't get a person's body in or a person's body out of the window necessarily. They were small windows. But having the deck there, the firefighters that had to introduce the water into the window were limited. They couldn't get a good angle to, bounce it off the ceiling or anything like that. It's however they were able to get the line in the window and do what they could with it. And then the third scenario is the one that we're looking at here, where you have basically 2 stories in the rear and a single story in the front, and you have direct access or full access to the basement in terms of a single door or a large sliding door or a large escape window, where you could make entry into the basement directly and fight the fire.
Yeah, and Dan, you may have already mentioned this, but you want to speak briefly to the concrete blocks and how that simulates the below grade condition?
Sure. So the concrete blocks are 2 feet thick, and they're stacked up. And then inside we have stud walls with non-combustible board, basically cement board inside, to seal it and fully simulate this below grade structure. So very little to no leakage.
Excellent. So Sarah, if you want to advance forward to what I believe is currently the 3rd slide, we'll talk a little bit about some of the challenges. And as it says on there, basement fires are among the most challenging fires encountered by firefighters. And there's 2 primary things that we're looking at with this. Obviously, you know, it's a dynamic fire ground situation. All kinds of different things can go well and can go poorly. But when we look at basement fires and we review the case studies and we review the firefighter fatality incidents that have happened, oftentimes they're grouped in basement fires into one of these two spots. And anybody that's tuning in today, I want you to think for yourself. Think back over your own career. And all this, and any study that you've done on firefighter line of duty deaths and injuries and stuff like that, and the number of significant incidents that you've read about or heard about or been a part of, where firefighters were seriously injured or killed in first and second floor fires versus the ratio of that same injury and fatality situation with basement fires. And I guess where I'm going with that is that there's the potential for significant injury and death in firefighters is significantly higher in basement fires. And if you look back at the statistics, and Dan mentioned earlier a reference to Gary Morris and IFC and some of the work that they've done there, you can also look at Don Abbott's Mayday project and some of the data related to that. And just the number of case studies that we frequently cite that would fall into one of these two categories as it relates to basement fires. You know, the collapse potential. You can go back to the Pang warehouse fire in Seattle. Arnie Wolf fatality in Green Bay, Wisconsin, and the lightweight truss collapse. All kinds of different case studies where firefighters have fallen through the floor. John Nance in Columbus back in the 1980s. Looking at operations in the exhaust portion of the flow path. You're probably familiar, those tuning in, with the Berkeley Way fire in San Francisco and the great job that NIST, Dan Madrzykowski and NIST and his crew did there with recreating that fire, as well as Cherry Road and things like that. We could sit here and insert a number of different firefighter fatality incidents into either of these two spots. And even just to build out that second one even a little bit further, operating on the floor above, even if it's not necessarily a basement situation. You could certainly classify the triple fatality in Keokuk, Iowa as operating in the exhaust portion of a flow path on the floor above. Not a basement scenario, but certainly still a scenario where firefighters are operating on the floor above. So that's really the two big ways in which these incidents can kind of go south, and there's a number of different case studies for both of those. And I'll take the point of privilege to say one more thing as it relates to collapse potential. In my area of the country, and in my little neck of the woods in Southwest Ohio, we've had 3 significant collapse incidents where firefighters have gone through in the basement. Bill Ellison in Miami Township in the early 2000s, Pat Wolterman just recently in the city of Hamilton, as well as Robin Brocksterman and Brian Shira in the Squirrel's Nest Lane fire in Coleraine Township. And so, and in fact, I just did a basement fires class last week and had some members from those organizations in the class and had a lot of good things to say about it. So that was a privilege for me to get to interact with some of the folks that have directly suffered as a result of these incidents. So anyway, just I won't go on too long here, but collapse potential, the possibility of going down into the basement, as well as operating in that exhaust portion of the flow path, particularly if there's low level ventilation, were the 2 big challenges for these basement fires. So Sarah, if you want to go back a slide, we'll let Dan speak to the layouts.
So basically, there's a lot of definitions that people use for basement. Some people say that a cellar is, 51% above grade or 40 or 50, at least 50% below grade, and a basement is 51% above grade. People have all sorts of different definitions, a daylight basement, things like that. We considered all these below grade fires. The real key difference between, I would say, what's considered a old school fire in training and current day fires that you work with on the fire ground is the amount of ventilation available and where the ventilation is. Ventilation directly to that below grade portion of the structure. So in the case on the left, we have no exterior access. There's no windows. There's no doorways that lead to the basement from the outside. Your only access is through the interior. And as a result of that, the fire is going to be vent limited, but it's also not going to have the potential to entrain new air with oxygen in it. So you won't be able to increase the heat release rate. So that's going to slow down the burning rate. It's going to increase the time before you have a collapse risk. And it's limiting the potential, if not eliminating the potential, to flash over. So you're going to have an intake at the front door. You're going to have exhaust at the front door. Based on the experiments here and some of the other experiments we've run, you're going to have a relatively lazy smoke flow and cool temperatures at the front door, which could be a little misleading because you could have an active fire, although relatively small, in the basement. Then if you look at the center position, now we have small side windows that feed directly into the below grade fire compartment. And they could be intakes, they could be exhaust, they could be, pulsing, so that sometimes they could be pulling air in, sometimes they could be pushing smoke out. If you have windows on both sides of the structure and there's a wind on one side of the structure, you could have intakes on one side and exhaust windows on the other side. So this enables the fire to get bigger, have a higher heat release rate, and it's still going to be vent limited. And then you could see that at the front door, you're going to be met typically with a front door full of smoke. We're typically not going to have an intake in this scenario. And then the last scenario is direct access to the basement. You've got a walkout door or something like that. And you can see now that our neutral plane, or where we're going to have our air intake, is going to be at that opening to the door or large window down there. And again, we'll have full exhaust at the front door. So in terms of a size up, you'd see that. Here, especially, you have great potential for that basement to transition to flashover very quickly once that door is opened or once that door or window fails. So that's really the big difference in the behavior of the fires. How much air can we get to that below grade compartment?
Dan, it was interesting poring over this data as far as the no exterior access and limited exterior access situations, how they always went vent limited, and barring any additional ventilation, oftentimes just kind of crapped out on their own. And a piece of the program is Chief Callahan from DC Fire speaking to the idea of why were we so successful with so many basement fires over the course of the decades and decades in Washington, D.C., and yet Cherry Road happened and things didn't go as planned for them that day. And as he speaks to in the program, in one of the video clips in the program, a change in that low-level ventilation, obviously, in the Cherry Road fire, for those that are familiar with it. And oftentimes, I think when people are successful in basement fires, they're able to make that push down the interior stairs. Obviously, it's oftentimes in one of those no exterior access or at the most limited exterior access situation. I thought that was very telling in the data that it was almost, like you said, almost impossible to get those scenarios to flash over without some type of additional ventilation. So Aaron, I want to kick to you and just based upon these three different options here, the no exterior access whatsoever, only ground level basement windows or some other type of limited exterior access, and full walkout. What experiences have you had in each types of these with any maybe close call or significant incidents in your own career?
Well, it's interesting that, the more I look at it, the more stuff comes to mind over the years that I probably have forgotten. But the vent limited is interesting because the house that I live in is a 3-bedroom ranch, and I bought it. It had a finished basement, had a bedroom downstairs, and there's the only access is through the interior staircase. And it really does concern me just on a personal level. I've been in those fires where we did the searches down there, and it's thick and it's chunky, and even if it's hot, it's a problem for us just simply because of not having the ability to get the smoke up and out quickly. And the heat does build for a while until we can do that. So it's a personal concern. When I was a chief, I had a firefighter get stuck in a sump pump hole in the basement of a house doing a search for victims with reported victims in the basement. And his foot got caught in the sump pump hole between the piping of the pump and the hole itself. And back then we didn't call Maydays. He called, "Oh crap, I'm stuck." And this was probably the early 90s, and he ended up coming out without a boot. He pulled his foot out of there and got out and came out without a boot. But scary stuff, and could have been nothing says that wouldn't have been a possible line of duty death report had he not been really thinking. So that type of fire is a problem for us. one of the things that I think we have to look at is we go back and forth over how much we're going to commit to what type of fire. Big thing with basement fires to me is what personnel do we have on location and what's our water supply? Because if we have a limited water supply and we have short-staffed crews, we really have to be concerned with not only the first line but the second line and getting crews in there and then getting them back out. And to me, with the inexperience that a lot of departments have, that's a serious concern. So that becomes the issue. When it comes to the limited exterior access fires where we've got some basement windows, these fires, okay, we can get a little bit of ventilation going. Maybe we can get a line in there to make a little knock on the fire, but our angles are usually really bad. So unless we have a window right where it's at, we're going to be hampered in that. And the other problem is, how many times do we have somebody a little less educated in flow path, in ventilation, and in fire dynamics, taking out every window because they think this is going to really help the firemen? Maybe it will, but it certainly doesn't help the lady and her child that are down in that basement, you know, in the flow path or near the staircase or whatever it may be. So, yeah, we can get some quick water on the fire, quite possibly, but there again, it may be where the quick water on the fire is far better served going from the interior as fast as we can. And again, manpower, person power, however you want to put it, I think that determines a lot of what we're able to do. In a place, in some of the bigger cities that are heavy staffed, place where I work, where I run 4 on my engine all the time, I think I have the personnel to get a line in and make a hit and really make an effect on somebody still inside. But in the town that I live in, where they may or may not get their rig on the road that day, and they're waiting for the military base to get access to come off, it may not be the way to go. So these are the dynamics that we have to look at from a personnel standpoint, in addition to what we're learning from fire behavior. And those are things that I've seen in my career. As far as full walkouts go, around here, all the new houses are big and they're full walkouts, and we've had some pretty intense fires, but we could stretch right in from there. Take a line around the back, make a push right through where it's venting, and guys have had luck doing it. Other guys, their feeling is we're still making the push through the center of the house. We get into that center staircase, go down, and it's already venting, so we've already got quite a bit that's going out. Again, it depends on the strategy and tactics that each department is working with. And if they're making up their minds prior to the fire, that's one thing. But if this is all new to them and they haven't practiced it, drilled on it, and understood what's going to happen when they stretch to certain locations, that's really not the time to learn. So this is something that they have to drill on prior. With us, we have lots of Bilco doors and lots of converted basements with drop ceilings, things like that. Places where we have the potential for hidden fire, and that has been an issue with us. We had a close call at work. Crews made a really good push into a single-family ranch, doing a nice job, 2 lines in service, and they ended up getting the lines tangled up, slowed the advance. Fire was running pretty well in the void space between the drop ceiling, and the next thing you know, they ended up in a bad position. We pulled up literally as the RIT, and as we were pulling up, they were calling the Mayday. The chief ordered us to cut the Bilco doors open. As we finished the cut, the crew was pushing the Bilco doors open on us. Thank God it wasn't, again, another LOD, but it could have been. So these are the things that I've seen in my career, and I'm sure I'm forgetting dozens of fires that we've been to over the years that were affected by this. But this, again, goes to the officer doing a good size up, knowing where you're at in your district, knowing if I go to this part of my district, it's big McMansions with walkouts, knowing that if I go to this part of my district, if I'm on certain parts in Hamilton, I know that I've got row houses and they may have some common basements. So we may have duplexes with common basements. So it's all about knowing our district and sizing it up and understanding what we're seeing when we get there, and practicing it before we ever get there. So.
Yeah, Aaron, I definitely appreciate the perspective. That's great stuff about staffing and how it dictates tactics and stuff like that. Absolutely true. I think it's and it also I think it's also kind of highlights, hearing some of the things that you said, the importance of looking at the data, right? One of the things that I think Dan will probably speak to when we bring up some of the slides as it relates to the study is, even if we can't get a line directly on the seat of the fire, just the ability to do some upper layer gas cooling could potentially be beneficial to us. Like, for example, in one of those ground level windows or something like that, even if it's on the non-fire side, could potentially have a positive impact on the overall operations in there. And I think a lot of the data kind of speaks to that. And then the other thing that popped in my head looking at those things, keep in mind, although we're talking basements today, please remember that full exterior access basement layout that you saw in that slide, think in your head of VEIS, right? Because even if when we get outside the realm of basement fires, a first floor fire with an open front door, I mean, that's the same concept as going in an upper floor window for VEIS, and kind of highlights how important that isolation concept is in VEIS. It's very very similar concept. So with that being said, we're kind of halfway through, so I'll very briefly throw out again the hashtag FETalk. If there's any questions that you have for Dan specifically, and you want the expert answer, here's your chance while he's on with us. So hashtag FETalk. I'll try to keep an eye on my Twitter feed and pick those up as we go. So with that being said, let's roll forward. Let's get into some, I believe, maybe tactical considerations were the next set of slides on there. And I think, Aaron, you're jumping off, brother?
I am jumping off. I got to get running. I got to get on the road to the Pennsylvania Turnpike in a hurry. And but I can tell you that when I get to my hotel room after I'm done teaching tonight, I'll be checking out the archive for the second half. So I really appreciate it. I'll talk to you guys.
Safe travels, Aaron.
All right. Take care.
Excellent, brother. We'll see you.
I'll see you.
Okay, so one of the cool things with this study is the UL and the staff at Delaware County did a lot of water flow tests with different devices. One of the things that it's important to realize is that we've got to keep our heads on a swivel as an industry for maybe what's old is new again, and maybe new things that come along the pike. So all these different devices were tested, and I'll let Dan speak to some of the specifics of these different water flow devices and what worked well. I mean, everybody's got the old Bresnan distributor in their apparatus, but it's one of those kind of things where, have you ever had it out past drill school, or how many times have you actually used it at a fire? So they got all those things out and did some flow tests with them. So Dan, go ahead.
So if you're kind of looking at the picture and we're going from left to right, you see that you have your adjustable spray nozzle, also known as a combination nozzle, or in slang, the fog nozzle. And we use that in both a straight stream mode as well as a narrow fog mode. And then you see a penetrating nozzle, 125 gallon per minute penetrating nozzle. That one produced a very fine spray, and it spread about 20 feet in diameter. Then we have the Bresnan distributor on an applicator type of appliance. And that one did fairly well, although its pattern was pretty tight, and it threw a lot of water up high. Next to that, you see a cellar nozzle. And that's like 4 small fog nozzles on a rotating device. And you would also put that on the long pipe to drop it through a hole in the floor. That one, again, had very good water distribution. Directly above that is a fog nail. So we tested the fog nail. It was flowing about 15 to 20 gallons per minute. But we didn't use it in any of the fire tests just because the way our structure was built, it was having trouble going through the whole floor and getting the tip down where it needed to be. In addition, it appeared that we would need to move it several times to get it to be effective. So that one really didn't make the cut for the fire tests. Then you see a smoothbore nozzle, 15/16, and that's attached to what we referred to as the hockey stick applicator. That was provided to us by Bill Guston from down in Florida. He saw that we were doing basement research, and he sent us a pipe that his firefighters use on basements in Florida. And so they don't have to have their face down by the window. They basically just stick the nozzle end through the basement window and go to town. So that was interesting. We wanted to try that out. And then last but not least is the long red penetrating nozzle, 150 gallons a minute. It can also have higher flows at higher pressures, but we ran it at 150 gallons a minute, and that had pretty good effect as well.
Very good. So, Sarah, let's roll on forward in the slides, and I think let's just leave the slides up. They'd probably rather see a close-up view of the slides than Dan and I's pretty mugs anyway. So I'll go through some of the tactical considerations, and Dan, please tag in as we go here. Anything that you want to add on any of these? Number one, size up is a must, right? We all know that, we all say that, but I think too many times in our business we say that on promotional process assessment centers and things like that, and we give that right book answer, but are we really doing it justice on the scene? I think sometimes there's a disconnect between saying that in training and saying we're going to do it, and it's in all our procedures and manuals and things like that, but then pulling up on that scene and the smoke's coming out or whatever, and then just going straight to the front door. And in that moment where we need to do it the most, just kind of defaulting back to, oh, we got to get straight to the front door as quick as we can. We really have to be disciplined as company officers and complete that full 360-degree walk around, looking for primarily, number one thing, exactly what we're talking about today. Is there a basement, and what is the access to that basement? Obviously, there's all kinds of other size up things that we're looking for as well. Equally as important, any victims at windows on the Charlie side and things like that, absolutely. But the presence of a basement and what that means to our tactical operations is critical, and it has to be done right at the very beginning, because if you have a situation with a walkout basement, most of the time, the majority of your time, of the time, and I'm basing this opinion on a number of case studies as well as the research in this project, the vast majority of the time, the best place for that first line on a walkout Charlie side basement is the Charlie side, attacking on at that grade level on the Charlie side, and we have to get all the way around there to see if that's the case, and not just a partial 360, right? Not just around enough to take a quick peek at the Charlie side. That's something that's highlighted in the NIOSH report in Hamilton from Pat Walterman's fatality in the basement fire. There, we really need to try to get all the way around that and get a full look at that Charlie side. So size up is absolutely a must. Below grade fires, likely to be ventilation limited. That was one of the things that I found very interesting as we go through this class and all the research that Dan and his team did with all the instrumentation there. They found that the vast majority of the time, unless there was something else like a walkout slider that was vented, these fires they struggled to build because they were pulling oxygen from everywhere throughout the structure, but it just wasn't enough to sustain that combustion and transition the compartment to flashover unless there was some significant change in the ventilation. And certainly that was the case with no exterior access, was even the case with limited exterior access. So, Dan, go ahead. Pick up where I left off there.
And it was also ventilation limited even when we had the sliding glass door open. And we actually—
Until that top slider got popped?
We had one case where we were doing a vent upstairs, changed the scenario for us quite a bit. And then we had another scenario where when we broke the second half of the slider downstairs, that then provided enough air to allow it to flash over. So it is, they are vent limited fires. And then what that means for victims in those fires is that the toxicity of the gas and the lack of oxygen in the fire gases that are going upstairs, it's pretty extreme.
All right, very good. So coordinating ventilation with water application required to limit the growth of a ventilation limited fire. Absolutely. Time and time again, we're talking about the importance of that coordination. And again, when we look at case study incidents and when we look at firefighter fatality incidents that have happened in the past, we never do so with anything but the utmost respect for the firefighters that lost their lives in the line of duty. None of us are perfect. None of us have ever been to a perfect fire ground. But I do think it's important to look back on some of these incidents. And when you talk about coordinating ventilation, I think it's very important for anybody that's not familiar with it to go back and review Cherry Road in Washington, D.C., where Lewis Matthews and Anthony Phillips were lost in that fire. And we won't go into necessarily the specific details of that incident just in the interest of time, but coordination is absolutely critical, and rapid water application, especially in a scenario like that with a walkout on the Charlie side, where there's a significant fire condition. Water application into the below grade space is key to cooling the gas and reducing the chances of flashover. Just to speak to that again, and I'm a little redundant because I think I said this a few minutes ago, but just getting water into that space was proven to be beneficial. Cooling that upper gas layer, even if you're not directly hitting the seat of the fire, cooling that upper gas layer, slowing that pyrolysis process on any wood members that are up in that ceiling layer is critical. Sarah, you want to roll on forward to the next one? All right. Effective water application into the below grade fire compartment reduces the fire hazard throughout the structure. So I'll go back to one of the things that Dan said just a second ago. And Dan, I'd really like you to speak to the numbers on this a little bit more, because you can certainly do it more intelligently than I can. It seemed as if the oxygen concentrations throughout the structure improved pretty markedly and pretty significantly relatively quickly after the water application. And when it comes to discussion about exterior water and rapid water versus getting the line inside between the fire and the victims and things like that, oftentimes on the internet discussions and whatnot on social media, there's a lot of talk about, well, temperature is only one piece of this. Temperature reduction's good. We see what the thermocouple data is telling us on all these different studies, but what about the victim? What about the victim and the environment that they're in outside of the thermal piece, about the smoke and the gases and things like that? And I thought it was notable and significant in a lot of these data sets with this basement fires experiment that the oxygen concentration jumped up very quickly after that water was on the fire. Can you speak to that a little bit?
Yeah, so getting water in there, and we'll see it in a couple of the pictographs coming up here shortly, is as far away as the open bedroom, which was sort of as far as you could get from the basement stairs and still be in the house, we were seeing transitions of the amount of oxygen in that room increasing dramatically once we put water on the fire in the basement, whether it was through a side window or through the back walk-in door or what have you. It was making a big difference. And of course, the door upstairs was open, so that's helping exchange some of that air.
Many ways to make a coordinated and effective attack. We'll talk in a couple of the slides about different ways where the water was applied and how that was beneficial to the overall environment. When possible, it's best to fight the fire on its own level. Absolutely. If there is a way to get water on that fire, either from the Charlie side walkout, from a ground level basement window in a limited exterior access scenario, or even some of the things that we'll look at in just a second, which is potentially going down through that floor. Any way that you can first apply water on the fire zone level. And again, I always go back to case studies, but where the fire was eventually put out on Cherry Road in DC was from the grade level. If you look at Berkeley Way in San Francisco, where the fire was eventually put out, was on grade level. And so if there's any way to get water on the fire from the level that it's already on, that's going to be our best bet. And occupants behind closed doors may be protected. Absolutely, the data was showing. Dan, correct me if I'm wrong, but I mean, you weren't even coming down below the 20 range in the closed bedroom door throughout in most of the scenarios. With
it was starting to come down a little bit, but certainly it was still very tenable. The people were rescuable in terms of temperature and oxygen concentration and lack of CO and carbon monoxide in there. So that was very valuable. So it just goes to show that even though you've got flames blowing out of the back door, maybe out of the kitchen door, it was still tenable in a bedroom down the hall with the door closed, isolated from the fire flow path.
Absolutely, and UL has a tremendous program with the Close Your Door for Life campaign and all the educational materials that went out with that. Truly should be a piece of your overall fire department operation is preaching that message of keeping the door closed. All right, Dan, you want to speak to what we're seeing here?
Sure. So what we're looking at here is one of the thoughts that the technical panel had was, let's use the tools we have and see what we can do with that. So if you have an adjustable combination nozzle, what if you just shot a straight stream through the floor? Well, as you can see in the picture on the right-hand side, that if you applied 150 gallons per minute straight stream and didn't move it around too much, just through a hole in the floor, the bulk of the water ends up on the floor. So we're not doing a lot of gas cooling there. Whereas if we have a fog nozzle, you can see that we're breaking up the water a little bit, and that's going to be somewhat more effective. And needless to say, the wider we angle out that fog, the more effective it will be in terms of gas cooling. So if we go to the next slide, we can look at some data from a fog stream that was a wide fog that was dropped through the floor, cut just inside the front doorway. And so that little blue icon in the right-hand image is showing where the water was making into the basement level. You see we have green arrows around the side windows, that we have side windows open in this case. If you look at the picture on the left, that's the upstairs level, and you can see that we have flow out the front door, we've got flow out the kitchen slider, and of course hot gases coming up from the basement level. As we kind of go around the picture, one of the key things is once we introduce the fog stream into the basement, we drop the temperatures in the basement from peak temperatures over 1,000 degrees Fahrenheit to around 350 degrees peak temperature, or 300 degrees peak temperature in the basement. And perhaps more importantly, if you're trying to approach the basement to make a top-down attack, you'd see that where the firefighter's face would be if you're crawling was initially about 570 degrees Fahrenheit, with hot gases hitting the firefighter in the face coming up the stairs. The hot gases are coming up the stairs at about 7 miles an hour. By putting the fog stream in there, we cooled those temperatures at that location down to 160 and dropped the velocity to 300 degrees. So that provides the firefighter additional safe operating time. And perhaps if when the firefighter made entry, there were a collapse into the basement, the firefighter might sustain injuries from the fall, but not from burning up, because, you know, we basically got the fire knocked down just with 150 gallon per minute fog, you know, through a hole in the floor.
Yeah, one might think, just based upon a lot of the discussion with fog streams and the air entrainment issues, and how that's definitely a no-no when you're flowing into an exterior window, and some of the detrimental effects of that and reversing that flow path. One might think that flowing that fog stream into that hole would create some type of a pressure wave or an increase in that velocity up the stairs, but obviously that was not the case. In both cases, dropped the temperatures as well as the velocity on that approach for the interior crew, as you mentioned.
And that's one of these things we have to remember, is that when we cool gases that are at 1,000 degrees, they contract, and that offsets some of the pressure increase that they're providing, and reduces the flow, reduces the pressure down there, which is why you don't see heavy steam blowing up the stairs.
Right. Okay, Sarah, you want to advance forward?
So now we're looking at a smoothbore nozzle, and it's attached to the hockey stick. So you can sort of see that if we were at ground level and putting the nozzle in the window, it shoots straight across. We did a similar thing with the straight stream, and the next pictograph on the slide shows you the results of what we had with the straight stream. And there you see in the lower, I guess, B side, if you will, AB window, the straight stream where we have the blue arrow, that's where we introduce the water. So it's on the side opposite the fire side, and we have the fire is intentionally shielded by that mechanical room and the stairs down in the basement. And so we know that we can't get the water directly on the seat of the fire. And that plan is intentional. And what we do see, however, is that we have very good impact by flowing water. And again, we can't get that high angle and break it up on the ceiling. So what we're doing is flowing water straight in the basement, and it's hitting the walls and splattering and turning into a broken stream on the walls. And it drops the temperature on the fire side from the peak temperature of, again, close to 1,100 degrees Fahrenheit down to about 320 degrees Fahrenheit. Notice again at the peak temperatures and velocities at the top of the stairs, we've got 700 degree drop to 250 at the ceiling, 550 degree Fahrenheit from where the firefighter's face piece would be, dropping to about 160. And notice that the change in velocity, not only do we decrease the flow from 7 miles an hour of hot gas hitting the firefighter in the face, but we change the direction of the flow to 3 miles per hour of cool air coming from the upstairs down the basement over the firefighter to cool them off. So, I mean, this is a big, big transition. Another point you might want to note is look at the open bedroom in the images on the left-hand side there. And the open bedroom oxygen concentration went from 13.8 to 17.5 at 4 feet above the floor within about a minute of application. So, I mean, we're changing things for the better throughout the entire structure.
As well as the oxygen concentrations in the basement itself, right? Significant improvements there. What's the time difference here in what we're seeing, Dan, from one piece to the other?
This is all happening in about a minute.
Okay.
So we're flowing water typically for about 30 seconds or so, and then shutting the water down. So we're doing these changes typically with less than 100 gallons per minute of water. So again, it brings in this concept of using tank water and being very fast and all that sort of thing.
Absolutely.
And not opening up and letting the fire grow before you attack it.
All right, very good. I think that I hate to sound like a broken record, but I think that oxygen concentration information is absolutely critical, a critical piece for people to see on this. Just that rapid water application not only reduces temperatures throughout, but does in fact quickly increase oxygen concentrations throughout. And I think that's a piece that sometimes gets missed in this online fray back and forth about tactics, is that there's absolutely a gas concentration piece to it as well. All right, let's move forward, Sarah.
So in this one, this is sort of attack it on its own level, in this case with a transitional attack. So the attack was made through the sliding glass door. So you can see in the basement image that the sliding glass door is hot gases going out the top, fresh air coming in low. That's also where we introduced our stream. And it's kind of interesting that we had peak temperatures on the side of the basement where if you look at the fire icon in the basement, where we started the fire, we're only about 1,000 degrees. But on the other side of the basement, opposite where we started the fire, but where the fresh air is, the peak temperature is higher, 1,350 degrees. Notice with the quick rapid introduction of water, we dropped that temperature to 200 degrees. And on the fire side, the intake side, 160 degrees. Again, big changes in the oxygen concentration in the basement, going from about 2%, 4 feet above the floor, back up to over 20% very quickly. The temperatures at the top of the stairs, I mean, you just couldn't get down the stairs here. These are the kind of scenarios where we have line of duty deaths. We have conditions at the top of the stairs in excess of 1,300 degrees. We have hot gas flows at 18 miles an hour. That's lethal to a fully protected firefighter. You're going to get hit with that kind of heat and drop. It's rarely the case where you get to move or take an action after getting hit with a flow like that. So, these are the kind of scenarios we're seeing in the line of duty deaths. Notice that water in from below very rapidly changes the conditions at the top of the stairs to 160 degrees Fahrenheit, and again, just a 2-mile-an-hour flow. So conditions that gear can withstand, so now you can make it down the stairs and finish putting out the fire, get your searches done, things like that. So a little bit of water can really enable you to do all the tasks and the tactics that you want to do in that structure, both downstairs and upstairs, very quickly. Again, notice the conditions in the open bedroom. We went from less than 1% to 18.5%. So there's a lot of changes going on pretty quickly in this structure.
And the coordination piece, even in the walkout scenario, even in this Charlie side walkout scenario, is really critical. There's a neat clip in this program that shows kind of a side-by-side view of ventilation occurring at the same time in the walkout level, and on one side of the screen they're immediately starting to flow water, and that 1 3/4 hand line that they have is able to effectively control that because of the fact that it was applied rapidly. And on the other side, when the ventilation happens but the hand line is delayed, when the hand line does get up there, it doesn't have a chance against this thing because it already has so much head start, and the heat release rate is so much more significant because of that inrush of oxygen that it had. So even in these Charlie side walkout scenarios, maintaining the integrity of the any openings that we can control is absolutely critical, so our water stream is more effective when we do get it in place.
Yeah, and it's the collapse potential here is incredible, right? Because we're seeing that in the first 5 minutes of even the fires that put themselves out, we were having burn through of the web in the wood eye joist or wood eye beam. And we know from furnace tests, we know from other structure tests that we did, anywhere from say 2.5 to 6 minutes, you're going to have the potential for losing the structural integrity of the floor. And so in cases like this, where it's freely burning out the back, and coming in the front door, your collapse potential is very, very high.
Absolutely. And just to, before we only got about 5 minutes left here, but just to plug a couple of quick things from and some of the work that Dan did at NIST. I'm really, really high on these videos that NIST put together, case studies using the fire dynamics simulator and the computational fluid dynamics technology to really recreate these in very vivid detail, recreate these incidents. I would absolutely implore anybody that's watching today to go look up the 57th Avenue fire in Prince George's County, as well as the Berkeley Way fire in San Francisco, for a lot of really important lessons learned and laid out in very in a very vivid, meaningful way. And a lot of tremendous work went on with those, and I hope that stuff continues. So Sarah, you can click on forward. All right, so this is neat. I wasn't able to be at this, and Dan, I don't know if you were or not. I know Steve was. Obviously,
I was. Yeah.
Steve and Steve are there in the picture. But a really neat thing happened at the Congressional Fire Services Institute dinner that was just the week, I believe it was the week before FDIC. As far as the awards, the two awards, Dan, correct me if I have this wrong, but those two awards were presented one to each organization, correct?
That's correct. Yes. So we are sharing this Paul S. Sarbanes Fire Service Safety Leadership Award, and it was granted in large part due to our collaboration on the educational products that we're putting out, and that's quite an honor.
Absolutely, a very proud moment for sure for both. I talked to Chief Pegram about that, and a very proud moment for both organizations for sure. And this truly has been a great partnership. And Dan, I said it earlier, but I'll say it again. We can't thank you enough for all of the time that you put in on this, as well as providing your technical expertise to myself and the rest of the instructor cadre and things like that. I hope that we'll make you proud with delivering this information all across the country. For anybody that is tuned in, please go to isfsi.org and check out the website on there for the current schedule. There's new classes being added all the time. It's covered under a federal grant, so it's free to attend and to host these classes, and it's really great stuff. So to finish up, Sarah, if you want to click to the next slide, I'd like Dan to speak to Lieutenant Letourneau.
So sadly, we lost one of our partners. Matt Letourneau was a career firefighter with Philadelphia Fire Department. He was posthumously promoted from lieutenant to captain. And Matt is an instructor at the Delaware County Emergency Services Training Center in Pennsylvania, where we ran all these experiments and have run previous experiments. And Matt has been one of the guys to come out and work with us and support the firefighting activities. And in the case of the basement fires, he was on the technical panel and working with folks, as well as doing hands-on. You can see him in the photographs there in the yellow helmet. And he provided his insight and what was going on in Philly in terms of basement fires and things like that. And sadly, he was killed in a building collapse. He was on the first floor. The fire was pretty much out. And when they went to check the second floor to do the search, the crew on the second floor fell into the first floor, and the floor collapsed onto Matt. And he died as a result of his injuries. That was January 6th of this year. So he was quite a partner in this and really gave his all. He was the instructor's instructor. If he wasn't there working with us for the day, but he knew that we were out there building something or working something or testing something else, when he got off shift, he would stop by and ask us, what is new? What can I teach my guys? What is the new thing that I can take back to my crew? And so we miss him, and he's quite a loss. And as a result, ISFSI and the technical panel and the program committee decided to dedicate the course and the report to Captain Matt Letourneau, in addition to the other firefighters that have been killed or injured as a result of basement fires. And so certainly on a personal level, Matt was a good friend. And it's, one of those things you're listening to the updates on the radio and online of what's going on, firefighter injured in Philadelphia. And I know 3 firefighters in Philadelphia. It's like, what are the odds of be Matt? But very sad. He was doing everything pretty well. They couldn't get a hydrant. They were on their 3rd hydrant trying to get water, as I understand it. And so the incident commander pulled them out of the house for a while, and then, they went back in sort of to mop up and to complete their search. And that's when they had the collapse. Talking to Commissioner Teal, in a lot of these neighborhoods, they're having a building collapse or 2 every week without a fire or a partial collapse, walls coming down, floors coming down. So they're, very old homes, certainly hardwood, old school lumber, but they've had 100 plus years to deteriorate or get weather damaged or what have you, as they're in somewhat disrepair. So it's really a loss.
Yeah, absolutely. And Dan, I appreciate you speaking to that. Tremendous. I didn't know him personally, but from all accounts, an absolutely tremendous person and a tremendous instructor, and a great loss to the fire service. And as you said, the program dedicated not only to Captain Letourneau, but the others, and we mentioned some of those. I really hope everybody leaves this and just immediately, closes this browser and opens up another one on their computer and starts researching some of these other firefighter line of duty deaths, particularly those that occurred in basements. There's a lot to be learned out there. So many thanks to Dan Madrzykowski from UL, our guest, as well as Aaron Heller that was here earlier. One of our other typical co-hosts, Steve Pegram, ISFSI President and Chief in Goshen, was out running the fire this afternoon, and so he wasn't able to join us. But many thanks. Join us again at the first Wednesday of the month next month for another focus on training, a different topic. I'm Brad French from Dayton Fire and ISFSI, and we really appreciate everybody joining us. Have a good day.